Okay, Professor, I have a question.
Yeah, go
Um,
ahead.
how would how do once I read in the text for this project we're doing for project two, because I am behind. I'm just behind. I had a um, procedure on my eye a week ago, and so it's kind of delayed me in my coursework. I guess I need to know once I read in the program, how do I read it inside of the try?
How
Like
do
I,
you?
I know how to read it inside of like am I just adding putting it in a list of like creating a try as a list? And that's where my problem is. So it's like um I have the try set up, but I don't have the data coming from the text.
Okay. First, try is something like a dictionary, right? So the whole point is that if you have the root point is no later, right? So and then you have A to G, something like that, right? So A to G, right? So some of them may be none, okay? Some of them may be none, actually no data. So A, for example, A right here, you actually may have a number. The number means that how many times is A actually show up in the text, right? For example, you use the Declaration of Independence, use the article. So here maybe the A's show up 20 times, right? But after that, you actually have the next level. It's a children list. Okay, children list. So children list, you may have A, B to G as well. So this one represent AA, the word AA, right? Maybe AA never happened, so this one may be new. But something like AB may have later. So AB may have two times, something like that. Okay, or AN may have later. May have word, may have word, may have used in the article. So you need to build some data structure like that to support the counting of the number frequency of the word in the article. So in a way, this one is used similar to a hash map. Okay, the whole try is being used like a hash map. Okay, so hash map is like you can check hash map. You have a word, okay, versus the frequency, how many times it actually being used. You have such a relationship, right? So hash map using the hash function of the string, and then you go to a certain location, but the location will store the frequency of how many times the word being used. So the whole try's purpose is similar to that. In the implementation side, how you implement it, okay, usually you can use an array or a list. That's good enough, okay. Actually, it's good enough. So here, if you don't use the one I'm using, you use say right here, you use a node, and that node you have a integer with a list, say that's okay. Each node. So here your root node maybe is a integer with a list, right? That's your root node. So initially your data structure is like this. Now let's assume that here you actually have a word being added. That word is an. Okay, that word is an. So for the first word added into the dictionary is an. So here in the list, okay, A will be created. At least A will be created. So A will be still 0 time because right here A never show up. It's an show up. So here you have a list, and that list you actually will point into this A, right? Is actually A, and then that A list will have A that's showing up 0 time, and then there's a data for n, this location for n, the location for n with 1 time, and then there's a list there, and the list actually is empty list. So by doing this way, you will already see that actually there's a and then AA no later, right? A no later, but AN actually is one frequency. You use that 1 time, right? So overall, you build up such a try, adding more 8 letters, right? More letters. And if you see the letter already in the try, you just increase the frequency by 1, right? Just like you use a hash map, and including the building this whole thing. So you need to implement the add function, okay, or increase function, whatever. You need to implement those different functions to maintain this try in order to make it work. Is that okay?
Okay.
As how to implement it, there's no limitation. You can try whatever way that can implement this try. So the whole purpose is that you implement this try, and then use it similar to HashMap, if you know about HashMap, right? Or map.
No, but I've seen it a
You
couple times, but I
you
don't.
must know about dictionary.
Yes. Mhm.
Dictionary is the word for Python. While map or HashMap is the word for
Java.
Java or C++. Okay, it just means the same thing, just string versus integer. Okay.
Okay.
String versus, but usually it's a string versus integer, but it's stored in the table, right? You have ANT, right? Something like that. That's actually HashMap's way. Twice way is different. Twice way, we don't store every letter. We actually end up in this way. We actually had a conceptual tree that is root no letter, right? And then there's a and then there may be B, and then there may be C, right? A have AN, right? B have BE, right? And something like that. Is that okay? BY.
That's
Understand?
fine.
Yeah.
Mhm.
So this is the way you use HashMap. This is the way you use try. And try, you have an integer associated with maybe 16 on this one, right? And
Right.
AM
Okay.
maybe 2 times, B may 3 times. So each node has the time. Time means that how many times the searching.
How many times it's in the? Okay.
Yeah, the words actually stop there. Does that make sense?
It does. It makes sense.
Yeah, and how to implement that, that's your job, right? As a project. I keep doing that. If you are late, it's okay. I take late submissions. Is that okay?
Yes.
Okay. Let's let me see. Do we how if we do this, it end up with multi-dimensional list. Multi-dimensional list actually Python's list is not 1 dimension, 2 dimensional, 3 dimensional. It actually is kind of like a node in C++. It really.
But in Python, isn't it considered multidimensional in Python?
You can call it multi-dimensional, but it actually is not multi-dimensional like a metric or tensor. It's not like that. It actually can be organized in any tree structure, right?
Got it. Okay.
So your list, you may have maintained a 2 entry. One is left, one is right? You can use that for binary tree actually, right? You can use that as a binary tree. Every node two field, you can maintain that as a binary tree. 3 field, you can actually do this, right? You can do a 3 tuple list. So 3 times, and then left child, right child, right? And this one may be null. Okay, null. Null, and here you may have child, right? And this represent a 3, 3, and 4, and 2. It represents such a tree, right? So list in Python is not really just array. It actually can be used as another thing, right? Is that okay? Hello, is that okay? Yeah, you can use a linked list. Yes, you can use linked list. Up to you. But here we are in Python, and you use a normal list is good enough. Okay, is that okay? And you need to build the constructor and everything. Okay. Any more question? Yeah, it's list and sublist. Yeah, all kind of list. It's just list. List is very powerful. Okay, you can build a list. So here you have number 3 times, and then it's a sublist. And inside this list, you have the A, B, C, D sublist. That's what the structure I'm using. Okay, here is the frequency. Here is the children's list. And children's list, A has its own list. And A also have the frequency number 3 here. And also it has it's a children list. Is that okay? The structure
Yes.
that, but you do not need to use the way I do, okay? That's just an example. You are encouraged to try different one. So basically what we learn from here is you have an article, okay, declaration of independent or whatever article you get. You go into the scanner and tokenization, right? So here we learn tokenization, right? And next step, we actually use this one to build a dictionary. And this dictionary actually is the string versus frequency, right? That we call it word over frequency. But I don't want you to use a dictionary. I want you to build the data structure try. The reason why I want you to do try, because this one is recursive. Dictionary is too simple, right? You know what I'm saying? And second, try you can exercise the evaluation tree algorithm to perform recursive or evaluation tree. That's the purpose why we use try over here. But the whole idea still be a text going into tokenization, going into the building the dictionary and try to calculate the frequency. Is okay? Still doing that. This build out as the so-called symbol table. Right? In compiler, you need to build a symbol table. Is okay?
I kind of got that from the reading. That's what you were having us do.
Mhm.
Is when we start to it makes sense. I guess it's just sometimes implementing it the correct way.
Yeah, just try, okay? Just try to build a data structure. I don't limit you to must do this or must do that. No, you try your best, okay? Is that okay? Okay. Any other question? This one is okay. I think try is okay. If you still have question, let me know. Okay. Any question? So that's this one is using the data. So in chapter A, in lecture A, we are on recursive functional programming, right? So we build this a different structure, and we also learn the currying, right? Currying and other functional programming. Well, right here, we just calculated the number of times that words show up, but you still need to deal with the grammar. So that's why we exercise currying and also exercise a dictionary as a simple table, right? These are building up your knowledge in Python, also the language translation schemes. Is that okay?
Yes.
And later, there are different type of programs, say evaluation of the expression. So must watch the video. There are several video in the lecture, and then those video may give you some sample code. Also need to download the sample code to try as well.
You know what? I have watched the videos. I did use some of the sample code.
It's
I have
okay.
watched it. Now, you know what? I did have a question. Because I guess I just didn't understand it. The postfix, the prefix, those examples, it was just confusing to me. I just didn't understand it.
You learn math like this, right? You learn math like, okay, 1 plus 2 times 4 plus 5 times 2, right? That's the way we learn a math. Okay, so basically this one is one of the each one of these are the binary operator. Okay, BIOPS. Okay, BIOPS. Each one of these are binary operator. So each operator is BIOP. Okay, BIOP. Binary operator. So binary, the so-called binary operator is A plus B. So there are two operands, and one operator. So if you operands actually operands, so let's use D. Okay, so you operand data 1 and the data 2, and the operator put in the middle. Okay, this one we call it infix, right? The operator is in the middle. Prefix means that you write it in this way. This one the prefix. You put the operator in the beginning part. Okay. If you do AB plus, then it's postfix. Okay. So these are three major notations. Okay. So now here actually this is expression we see right here. This one is actually a infix notation, right? But if I translate it into postfix notation, this one I should write this one first, right? I should write this one first. It should be postfix should be 2 4 times, right? This one actually should be 5 2 times, right? As a postfix. Okay, and then this one and this one, it should be 1 2 4 times and then plus. Okay, that's this portion. That's up to here. Okay, and this one is this, so it actually should be 5 2 times and then plus. This plus is between this operand and this operand. Is okay? So eventually we translate to this one. This one is the postfix.
Okay.
Okay. So let's see what's the advantage of having the postfix. Okay. Let me erase it. Okay. It's a 1, 2 times 4, 5 times 2. Okay. So here original expression is 1, okay, plus 2 times 4 plus 5 times 2. Okay, that's the original infix. Now I translate to postfix. So it'll be 1 2 4 times plus 5 2 plus. I'm sorry, 5 2 times. This one is times. Okay, 5 2 times. And then plus. Okay, this one is postfix. Okay, so we translated this one to this one. Then when we would like to evaluate the expression, okay, we would like to evaluate this expression. We evaluate this postfix. So we put the operator here, okay, 1 in the stack. Okay, and then second one I do a 2, push 2 in the stack, 4 in the stack, and then start in the stack. Okay, once I do start, I pop it out, put it here, 2 times 4, so I get 8. Okay, and then I erase this 2, put the 8 back to 8. Okay, put the 8 back to 8. Right? Then I see a plus. Now I pop out this thing, it becomes 1 plus 8. Okay, so then I actually pop out this thing and I push back a 9 to be there. Right? Now my cursor move up to my operation move up to here now. Now I push 2, I push 5, push 2 there. Then I push start there. Now I pop out this, I have 5 times 2. I pop out this 2. So this one's 10. I push back. So here I get a 10. Now my operator is finished up to here now, right? And I see a plus. Now I pop out these two things, 9 plus 10, it is 19, and then clean up, pop out everything, and I put the 19 in. So eventually the result will be at your stack 0 location. Is that okay? So PostScript has such a good advantage of easy to do translation. So let's see. Here
I
we
noticed.
yeah, is that okay? So here that's actually look at this. The whole thing is like, okay, you kind of have the a repeat system, right? You have a repeat system. You start to ask question. So the guy type in 1 times 2, 1 plus 2 times 4 plus 5 times 2, right? The guy hit enter for this. Now what happens is that, okay, internally it translates into this, right? So internally it translates into this. Then it used the scheme that I just described, push in, pop out, push in, pop out, whatever, and it give you 19. And that's the replay. That's the Python evaluation should be, right? Is okay? We are teaching you this. That's why that is very important. Yeah, it's actually a different notation to write same operation, right? Yeah. Okay. And something you may not know because you guys are so young. You guys so young. You almost like my nephew's age or my son's age. So, you know, the old days, HP used the PostScript calculator. Reverse Polish operation, right? RPN, reverse Polish calculator. Okay. When I was young, we need to punch in the PostScript operator to calculator. I'm not kidding. Okay. In the old day, we do use this prefix or PostScript calculators. It had been there for a while. I mean, so you may see some calculator it work like this. Okay. You type in 1, 2, 3, 4, 5, right? So whatever, 1, 2, 3, and then you hit enter, right? And then there's a 1, 2, 3 go into the computer. Now you erase this and you put a 4, 5 into there, right? And you push enter, so 4, 5 into there, and then you hit a plus. Or this one you don't hit enter. The second one you hit a plus. Then these two numbers will be calculated. Pop out, and plus, and then push back to the computer. It become say some number. And some number actually, and then you clean up, right? Clean up this one, and then at that time you actually hit say 2, right? Maybe hit 2, and then you hit division, and then the number will be divided by 2, and then push back to the step. So that's PostScript calculator. You know what I'm saying? So the infix calculator is just maybe 10, 15, 20 years, maybe just like that. Okay, PostScript calculator has been there for a long, long time, for probably longer time than the infix calculator. Infix calculator is just not too far away. Not too old, maybe 20, 30 years of time. That's because in the old day, when computer just come out, you do not have too big processor. The processor is very tiny, so they cannot afford the language translation scheme to be too complicated. And now it's actually more complicated, so the calculator is very robust. So the translation between infix and the PostScript is much easier. So now they start to offer this. They offer the 1 plus 2 and this kind of expression. And then you hit return, and the whole thing being translated into the PostScript, and then do evaluation, and then return the result to you. So now the calculator take this type of infix notation and be more efficient. Is that okay? Does that make sense? So this one you can read the PostScript calculator, but well, that this means that PostScript is a grandpa's technology. No, it still be used. You just don't know the museum of HP calculator, right? the algorithm is still there. Okay, it just already been get used to the convenience of the using the technology, but the algorithm still be there. If you really want to develop a new computer, the calculator model. Okay, so here you see, you want to do 4 plus 5, this equation, right? You need to do 4 enter 5 plus, so you calculate this function. Then you do 2 enter 3 plus, okay, and times, and then you have 6, and then plus, then you will plus 4 times plus 5, and then 2 times 3, and then plus 6. And then A enter 7 enter plus, you actually get A plus 7, and then divide. Then the previous data divide with it, and then 9, and then y raised to power x. That's it. This type of the button that you need to hit in the so-called reverse Polish notations calculator is supposed to be. Okay, is that okay? This RPM reverse Polish notation is a PostScript notation. And this subject is actually must-learn technology when we were in college doing the data structure. It's a must-learn technology. But nowadays, because this one already been built in a lot of libraries, so you use it, but you do not know that it was done in that way. Okay. But do you still need to learn this? Yes. If someday you need to rewrite a calculator or rewrite a expression evaluator, you still need to learn how to translate from infix to a PostScript, and then build in the evaluation tree, and then do evaluation. You still need to do that. Okay. And PostScript had the advantage of directly pushing the data to the stack and then pop out right away. Okay. Does that make sense? That's why we are doing that there. And after the PostScript evaluation, you should be able to write your own evaluation portion for the parser. Parser will need that. Parser have the grammar. Parser need to need that, use that. Okay. So some of the example is you can use part of the code. I don't say no. It's okay. You can try some of the code. Okay. In the chapter 14, 15 portion, we do have the example for the interpreter. Okay. So say chapter 13, 14, like 14. 14, we have some parser number 1 token rules. Okay. And next example, this 14 is for Lexer. Okay. So let's try to see this one. Okay, calculator. So remember to watch the video here. Okay, so here let me go on Python. Okay, and then the program is called calculator example. Okay. Sorry, it is called calculator example. Wait, I type it on. Let's see. Oh, next. Okay, I'm sorry. This is called Python calculator next. Okay, this one's tokenizer only. So you execute the tokenizer. So let me try chapter 15 one. Okay. Let me try different one. Let me try lecture 15. Lecture 15. Okay, no. Let me try 13. Okay, 13 here, we have a calculator parser. Okay, so let's try this one. The file name is called calculator underline parser. Okay, it do show up this parser. So right here, let me have 1 plus 2 times 4 plus 5. Is that okay? Is that okay?
Yes.
Is that okay?
Yes.
Okay, so that example is you can download from the website and you can try it. Okay. Jonathan, your question is I'm stuck at the list for the try adding function. I think the 20 signal. Yeah, the depth is the length of the word. Yes. Okay. You don't want to use these. Some people use other depths. It's up to you. Okay. If you try to use tuple, you try to use set, you try to use but try not to use a hash map. Okay. Try not to use dictionary. If you're using dictionary, you just not doing try. Okay. Okay. Use this tuple array, whatever you want to do is actually acceptable. But to try not to use a dictionary, because dictionary itself is a hash map. Okay. And you're trying to use a hash map to implement a try. That's a very strange. Okay. That's very strange. That's okay. Try your best. Okay. Our purpose is for you to try more different combinations.
So the add function that you did for the tree, would that be similar to the try add function?
Yeah, the size you can size actually you can do recursively. That's one way. The other way is that if you don't find the edit to be add word, okay, every time you try to add a word, right? If you try to see to be add word and it's not in the tree, you can increase the size by 1. You can use a separate counter. That's actually also okay. Then you do not need to runtime evaluate how many words in the tree. So every time you have new word, you increase by 1. That's okay. For the counter portion, okay, for the counter portion. Okay, any other question? Hi, Brian, how are you? Any question? Hello, hear me? Okay, it's okay. No questions, okay, I'm fine, okay. So this one, as you can see, we start from the programming language features, and then slowly we start to learn data structure, right? Review data structure, and now after review data structure, I want you to learn the recursive call and then scheme language. So some of you work on the exam and do not provide a scheme language. That's not acceptable, okay? Because we really want to force you to learn a different programming paradigm. Okay, that's the purpose. That's the purpose of the lecture 9. Okay, we do want to force you to learn scheme paradigm. It's not that hard. Okay, it's not that hard. With some practice, it should be okay. So now let me show you one more time. You actually need to install the Dr. Racket. Okay, you need to install the Dr. Racket. The Dr. Racket is a Racket language. It's a newer version of the scheme. It's not 100% compatible. So you need to download it, and then you actually bring up the Dr. Rocket. Okay, it's not 100% the same, but it's a newer version of the scheme, so it's okay. But most of the scheme's feature, you will be able to use it. Okay, so let me bring up this Dr. Rocket. I don't know why every time it's so slow. Let me close some of my windows. Okay, this is Dr. Rocket. So in a way, you must follow the functional programming's idea. Okay, do not try to go back to the iterative way of doing programming. Functional programming can be very pure. Okay, can be very pure. You try not to go back to iterative, imperative way of programming. Same thing when you do recursion. Try not to go back to the regular way of doing programming. Okay. So here, this one, every time you will start with some environment like this. Okay, let me close one. Okay. So there's a language record. You need to have this. Okay. You need to have this, but it's okay. Now, first thing is that you can define a variable. So here you can define x3. So x becomes 3. Okay, x becomes 3. After this is a loop. This loop will just define a variable x. So x now stored with 3. Okay. And then you can do define, okay, y 4. Okay, so y equals 4. So now I do have a y that's actually equals 4. Okay. And then you can do plus x and y. Okay. So this one is a prefix notation. If you look at it, and it actually is a list. So this one, if you use a Python to implement it, it actually is a list of the plus operator and then x and y. Okay. And here you define x was 3. So in the background, you store x with 3, y with 4. Then you evaluate this based on this environment. So with that, you will be able to evaluate it. Okay, so we do this. But right now, you did not get any result because these are just some rules. Okay, so you need to do a file save the definition. Okay. So save definition, I save to the weekly part. Okay, so right here we are week. I think we are week A, right? We are week A. Okay, whatever. Over here. So here I have a scheme 1, and then I should be able to run it. Okay, so I got 7. Is that okay? So this one we can actually put more complicated format. Okay. Okay, so this one become s squared plus 2x. Okay, is that okay? Okay, this one become like that, and then you can actually also do this. You can do fine. Okay, and then a function for poly. Okay, and after poly, you actually define a lambda. Okay, and lambda you have the lambda x. Okay. Is that okay? So the last one, we define a poly function. And this poly function is this function using lambda. So it's a 2x plus 3. Okay. And x is what? X is 3, right? Wait, x 2x plus 3. Oh, I'm putting 2 into that. So initially this one is actually 4 plus 3. Okay, and you got 7. Is that okay? So this one I can define a polynomial. Does that make sense? Spacing and indentation not important. Not important. You can write in very freestyle. You can do this. Okay? It's freestyle. So try to do this. Okay, try to do this. Try to learn this language. Okay. Reason why we need to use to really learn it is that in the lecture 16, we still do it. Okay, we still need to do that. Okay. Is that okay so far? Any more question? So this one you must think about things in this way. Okay, think about things in this way. Totally in the scheme language way. Okay, programming paradigm. Okay, what is programming paradigm? Programming paradigm is you do functional programming, you do list processing, you do everything. So when you use a programming paradigm, something you call it paradigm, you will have to think in really in that way. Okay. And you, in order to help for you to think, you must use a certain language that's written in that paradigm. Okay. So say when we talk about neural network, right? We talk about neural network, you have to think in neural network way. So neural network is not going to help you to solve 3 plus 4. It's not going to solve such problem. No, it is not. Okay. It is not. So neural network is a fundamental processing scheme, and then the way it actually will learn and will do computation. So you do see that there's several layers of neurons, right? And putting weight and sum together. So using that's the computation model, right? And you load your data into the computation model, and then you do computation in that way, and you do some evaluation and get a result. So in a way, this one is some sort of error function. You prepare a vector into the, and then after they shaking it, whatever they do, eventually they give you a result. Okay, that's the way you use neural network, but it's totally different from your traditional way of programming. It's not one statement after statement to do a thing. Okay. Any more question? Jonathan, still a question? No. Okay, when you do recursive, okay, functional programming, this portion schemes, okay. Let me show you in you when you do recursive. Let me talk about recursive one more, okay. So let's assume that we actually bring up this Visual Studio Code. So when you do recursive, please do not go back to the normal computation, okay. Do not go back to the imperative way of programming as well, okay. So you need to do everything in recursive way. Yeah, try to stick to the recursive way to do things, okay? So right here, if we have some, okay, this one is examples. UI, okay? So here, if we have a list, okay, so a list equals 1, 2, 3. So as simple as I want to print this one, so define rprint. Okay, so rprint recursive printing. So recursive printing, I need to actually process this a list, right? So I do need to have a one index, okay, and I'm going to print this one. So if actually index, okay, greater to equal to the length of the a list, okay. In this case, I just do return. So this one is the end of the function, okay. Otherwise, I'm going to do print, okay, a list index value, okay. And after that, I will call reprint, okay, reprint, okay, a list, and then index, okay, plus 1. So this one is the helper function for rprint, a recursive print. And then we define a function called print. Okay, so print a list. And then here you will do rprint a list, and then 0. So that one, this one is the regular code. Okay, this one is called helper function. But sometimes I use the same function name. Okay, sometimes I use the same function name. Sometimes I don't. Okay. This one don't call it print. Okay, let me see. This one I call print. Okay. So let's see. So here let's do print. Okay, I think they do not allow this one. So let's call this one print help. Okay, they do not allow a function of different. They do not allow the overloading in Java. So let me put a helper function with H. Okay. Okay, and you print out 1, 2, 3. So this one is the way we purely using the recursive to do printing. I do not use any for loop. Okay. Is that okay? Hello. Ashana, is that okay? Hear me? For us, when you do, no matter it's a recursive call or if you use it for the functional program, you must stick with the programming paradigm. Okay, you must stick to it. Okay. Sure. Project 2, recursive, non-recursive, up to you. I do not. It is a try, so you need to be recursive, of course. Usually, you will need that. Yeah. Can you do while loop to solve it? Yes, it's possible. You do while loop to solve it. Yes. Okay, it's possible, but it's very tedious. The iterative way of writing it would be very tedious. Okay, this is the recursive call. So you can think about more complicated program. Every single program can all be done recursive. And recursive way you can do it, you can also do it in the Redis way. Okay, all of the programming you can do the same thing. Okay. Okay. Any more question? Okay, if no question, can we stop here? Hello? Any more question? Okay, no question. Wish you have a good day, okay? Let me know if you still have a question, okay? Email me or try to post message on my Facebook. I'll take it, okay? Okay, thank you. Bye now. Bye-bye.